For reference, this is the table that I'll be talking about and we'll be using. All right, hey chemistry people, we're gonna do this lab here. This is a great lab to see the indirect evidence for electron configuration. It's tough to see electrons. In fact, it's impossible to see electrons. So this lab is great. Let me break it down here. First of all, we have a few things going on. I have this scrap piece of wood right here. Put that on a typical balance that you've used before. And then I have something you probably don't have, which is a very powerful magnet. It's pretty cool stuff. So we'll put that right there. And from that point, we hit tare, which zeroes it out. And then we have this piece of cardboard that we made a circle and put that so it doesn't touch the pan. That's pretty important. If it doesn't touch the pan, then what I can do next is put this very fancy ruler that has a slit, put into it, and I'll put that right on top. So basically I'm making like a little bridge here that the ruler is not touching the magnet. All right, here's kind of a close-up view. You can kind of see what's going on here. But that magnet is not touching that ruler, which is great. And you can see it has zeros right here. So what I'm gonna do, I have these little vials right here, and I wanna take this vial of, I'll explain in a second what those, why those formulas on the different samples are important. But we're gonna take this right here and we're gonna put it ever so carefully, and it goes to a negative number right there, okay? So essentially what's happening is this sample in here has magnetic properties, which is pulling this magnet up. And since it's suspended around this piece of cardboard here, I get a negative number on my reading. Now, if I go right here and I take this off, it should go to 0. Ooh, good. So then I can test different samples and put different samples and see how they react there. And you can see some are different, and that's what we're really paying attention to. So give you a close-up view there, what's going on. And I'm just gonna go through all these different samples and kind of give you the readings as we go. So let's get busy here. So I got this block of samples here. I'm just gonna go in order of what your table says. So make sure it's zeroed out. I take the cobalt. Cobalt's a pretty cool color there, purple. And again, it's COCl2. Now I don't care so much about the Cl2. What I care about is the cation that is formed when you lose electrons, specifically 2 electrons. And that's important, as you probably found out before. So I'm gonna put this right here, and I wanna see what my reading is. Now, I'm gonna give you negative numbers just to keep it simple, or excuse me, positive numbers, get rid of the negative. Obviously it's negative, it's pulling it up. But I'm just gonna give you the absolute value of the negative number. And my number is, oh, I'm leaning, don't do that, 0.22, 0.22. Great. Let's do the next one, copper. I would say probably more of a light blue color there. CuCl2, put that there. And that's barely anything at all. 0.06, all right? Next one, iron. Iron's kind of a cool color there, yellow. I put that right there. Hands off, 0.32. These numbers are good. I'm doing a good job. You never know, right? Manganese, MnCl2, going right in order. I'll put that on there. And okay, that's a little bit larger, 0.50. 0.50. Nickel, cool color there. Green. See what we get. That's a tiny one, 0.12. 0.12. And last but not least, and again, I'm checking to make sure that's a 0.00. It's been zeroed out. The zinc is ZnCl2. I'd say that's white. Pretty simple color there. And I'm getting nothing, so that would be 0.00. Cool. So that's pretty neat. You're gonna take these numbers, and if you look, you're making a graph, and The graph, I want you to pay attention to the directions because it says prepare a graph plotting the balance reading absolute value, which I gave you, so you don't have to worry about the negative number there. I'm going to put grams on the Y, okay? Put grams on the Y, and I'm going to put unpaired electrons on the X. And again, you get the unpaired electrons from the 3D orbitals. So take a look at your configuration and how did you draw those arrows based off of the rules and the principles we've learned. We've learned 3 major principles here so far, rules, principles. Use those rules, use those principles, look at your unpaired electrons, put those again on the X, put the numbers I just gave you on the Y, and you're going to see a pattern. And that pattern is important when you're answering the questions at the end of this lab. So take a look at that and see what your answers are, and that's pretty much the lab. A lot of writing and a lot of concepts, but not a whole lot as far as the lab goes, which is good. So pretty cool stuff. A nice way to visualize how electrons behave without actually seeing them. All right.